what if the most destructive force in the universe is also the key to its ultimate fate? We think of black holes as cosmic monsters, ravenous voids that devour everything, even light itself. But what if that's only half the story? What if they're not just destroyers, but builders, shapers, even the engines that power the very structure of the cosmos? Today, we travel beyond the known to the edge of physics, where space and time twist beyond recognition, to confront these mysterious giants. And what we uncover there might just rewrite everything we thought we knew about reality. Every black hole begins with a star, but not just any star. Imagine a titanic celestial body, dozens of times more massive than our sun, blazing with unimaginable energy. For millions, even billions of years, it burns furiously. Deep in its core, nuclear fusion acts like an outward force, pushing against gravity, a perfect balance that keeps the star alive. But one day, that fuel runs out, and when it does, gravity wins. In less than a second, the core collapses. Outer layers crash inward at nearly a quarter of the speed of light. The result? A supernova explosion so intense, it briefly outshines an entire galaxy. That's right, a single dying star becomes brighter than billions of others combined. And what's left behind is even more extraordinary. A core so dense that atoms themselves are crushed, collapsing into a single point, a black hole. A region of space where gravity is so strong, not even light can escape. And those are the small ones. At the centers of galaxies lurk supermassive black holes, weighing millions, sometimes even billions of times more than our sun. How do these giants form? No one knows for sure. Some believe they grew from the first stars in the universe. Others suspect they were born almost instantly during the Big Bang. And then there are intermediate mass black holes, strange entities that may bridge the gap between stellar and supermassive black holes. We've only recently begun to detect them, and they might hold crucial clues to how these cosmic monsters evolve. So what happens if you fall into one? From far away, a black hole is invisible, a pitch-black void surrounded by a glowing halo of twisted starlight. That light doesn't come from the hole itself, but from the matter spiraling in at incredible speeds, heated to millions of degrees in its final, desperate fall. The edge of this dark sphere is called the event horizon, the infamous point of no return. Cross it, and escape is physically impossible. Not even light can get out. To an outside observer, you'd appear to slow down, freeze, and fade away just above the edge. But to you, the one falling in, time would feel normal, until it didn't. Inside, gravity becomes so extreme, it tears apart molecules, atoms, and even subatomic particles. This process is known, rather gruesomely, as spaghettification. You're stretched into a thin strand of matter pulled by tides so intense they defy imagination. And then comes the core, the singularity, a point of infinite density, where the laws of physics, as we know them, completely break down. What lies beyond that point? Is it the end? A tunnel to another universe? a bridge through time. Some scientists believe it could be a gateway to a parallel reality. Others argue it might destroy not only matter, but information itself, a notion that contradicts the rules of quantum mechanics. The truth? We simply don't know. And that's why black holes remain one of the most tantalizing mysteries in all of science. For much of modern history, black holes were viewed only as destroyers. But recent discoveries have turned that notion on its head. Astronomers noticed something bizarre. Entire galaxies, including our own, seem to orbit nothing. At their centers is a dark mass, a supermassive black hole. The Milky Way's central black hole, Sagittarius A*, is over 4 million times more massive than our Sun. And it's not alone. Nearly every large galaxy we've observed has one. This raises a profound question. What came first, the galaxy or the black hole? The answer might surprise you. When supermassive black holes are young, they're ferociously active, devouring gas and dust at an incredible rate. As they feed, they release colossal jets of energy, creating quasars, the brightest objects in the known universe. This energy doesn't just escape randomly. It can compress surrounding gas, triggering bursts of new star formation. In this way, the black hole acts as a kind of cosmic architect, helping to build the very galaxy it sits inside. But there's a twist. Eventually, those same powerful outflows can blow away all the gas, cutting off star birth entirely. The galaxy ages, quiets down, and becomes a fossil. So, black holes aren't just destroyers. They're sculptors of cosmic structure, shaping the rise and fall of entire galaxies. For a long time, we've believed black holes were eternal, indestructible voids that would last forever. But in the 1970s, physicist Stephen Hawking changed that forever. He proposed that black holes actually emit faint energy due to quantum effects near the event horizon, a phenomenon now called Hawking radiation. This means black holes lose mass over time, very slowly. A black hole the mass of our Sun would take more than 10 to the 67th power in years to evaporate. That's a 1 followed by 67 zeros. But it means that even black holes have a shelf life. Fast forward to the deep future of the universe, long after all stars have burned out, long after galaxies have dimmed into darkness, the only remaining source of mass and energy will be black holes. This era, known as the black hole era, will see the universe become a quiet graveyard of slowly evaporating giants. And one by one, they'll vanish into a faint whisper of radiation, until, finally, the last one dies. What's left after that? A cold, empty void? Silent, timeless, and infinite? Black holes, once feared as devourers, will have written the universe's final chapter. We began this journey imagining black holes as terrifying forces of destruction. And in some ways, they are. They are also cosmic engines, creating galaxies, guiding the birth of stars, and shaping the evolution of everything we see. They are the beginning and the end, the Alpha and the Omega, the keepers of the deepest secrets in our universe. Even now, with everything we've learned, black holes still defy us. What happens at the singularity? Does information really vanish forever? Are there primordial black holes from the Big Bang scattered throughout the cosmos? Could one be passing through our solar system right now? The questions multiply the more we look, and that's the beauty of it. What do you think is the greatest mystery left about black holes? Is it the singularity, the possibility of wormholes, or the eerie idea that they may lead to other universes? Let us know in the comments below. If you enjoyed this journey into the edge of science and wonder, please like this video, share it with fellow explorers, and subscribe to our channel. Every click helps us keep diving deeper into the cosmos. Stay curious, stay bold. The universe is vast, and we've only just begun to understand its shadows.